Okay, so that's fine. You can run over. Uh, Hello, everybody. My name is Artem. I'm working as a solution architect in EPAM. I'm working for about like 10 years in EPAM, right? Like started as a manual key, then kind of moved to automation. After automation, I kind of moved to performance. After performance, I've moved to solution architecture, and now I'm kind of in a position of senior solution architect. Right, it's kind of my focus area is the performance optimization and security analysis. And today we're gonna talk about my experience of building security test automation platform, right? We've kind of, it was not very smooth, right? But at the end of the day, we kind of build a huge platform, take it out, and open sourced, right? So today I will show how it works. I will describe some gotchas, some issues we're having, and like how it actually impacts the delivery. So the first of all, why should we even start thinking about the security? It's quite a big market, right? It's like, well, 5 billion bucks in security testing by its own, right? But apart from that, there is yet another 4 billion which is paid by some sort of a fines because of regulation rules, because of some issues with threats or some other things, right? But that's which gives in total like about 9 billion. This market will never, I believe, grow up to the automation testing, right? But it still will be huge, and it will be growing and growing like up to 14, I believe, billions in next couple of years. So there are some jobs there. Let's start with a bit of a theory, right? What's actually in scope of a security testing, right? The first thing first is an big enterprise level organization need to run it as a programs, right? And the programs is basically enable security through all the chains of a software delivery process, starting from a review of an architecture, right? Starting from building a requirements, keeping all the security in mind. There is like threat modeling when the architects and security specialists drawing the landscape of an application and start drawing the things where the potential attack can come and assess the impact of every attack. But that's like more about the papers, right? The next thing is continuous security testing. That's about an automation, right? That's where automation come into play. And automation only start getting there. The market of security automation is very similar to market of a test automation about like 10 years ago. It's almost like a green field, right? And we'll kind of show that in numbers, and numbers are very impressive there. And the last but not the least is all of that hackers dudes who is doing their hacking stuff. They're trying to find the vulnerabilities, exploit complex flows to actually get to a system. One of them is hacking, another one is defending, and that kind of funny game, usually being shown on a TV, which is in fact not like that. And today we're going to talk about this, as you probably already know, right? Let's agree on a simple thing. If you have a question, just raise a hand, and we'll try to do it a bit interactively. Okay? Good. So, in order to do this, the simple question, that's actually what comes in mind. The first thing, just run this freaking thing, any kind of scanners, just take a scanners and run it in the CI. Why you need to kind of bother, right? Well, let's check how then things going. How do you think what actually goes next? What the security engineers spend their time on? Some ideas? Facebook, that's a good one, right? Not actually related to work. I was more like focused on the real stuff. Facebook is also real. No offense to Facebook. Yeah, come on. They run scanners. They trying to find vulnerabilities. They need to do a job. So like about 1% of the time, they run the code scans, right? Trying to find the vulnerabilities in the code, right? About like 6% of the time they doing dynamic scans, which is a bit more interesting. That's like application is live, you're trying to find either open ports or like trying to explode some XSS, SQL injections and all of that fancy words, right? But then next the good stuff. 68% of the time they actually trying to validate if the scan results is actually issue or not. That's freaking boring thing. You're kind of getting a huge list and trying to actually identify, is it actually a bug, right? And the rest 25 is validation of a fixes. If the security issue is fixed, okay, we need to validate it. And to that kind of waste, 68%, there is a reason. Because like the scanners are actually return about 85%, and this number is very optimistic, of an issues which is not actually a bugs, which is just like scanners think that that's a bug, which in reality is not. I believe like everyone back in the days saw the situations, even for functional automation, right? But there was a lot of flaky tests. Like 5-10 years ago, automation was not as efficient as now, and like tests were failing always, they were always red and things like that. No one knows like why it's red, because the automation is bad or because the application is bad. Like that's pretty similar now happening in security, the scanning solutions. They like return a lot of a noise, and this noise need to be processed because kind of there are some chance that there are some gems in there and actual vulnerabilities are hiding, right? So the actual work of a security specialist, most of the security specialists, looks like that. I borrowed this gopher kind of thing, but it's very similar. They like having a huge pile of all the findings. They kind of tracking them, moving somewhere. Some is burned because there's not an issue. Some is raised in a Jira, and then like actually what they do all the day long, right? And we actually saw that that's a space for improvement, right? Because the market now looks not like the best way, right, in terms of an automation. Uh, the products released with the security issues, which cause the fines, then all that billions need to be paid. The out-of-the-box solutions produce a lot of a noise. No one actually wants to kind of work with that noise, because like in order to understand if it's noise or not noise, you need either spend a lot of times of a developers or a QE, or have a dedicated person who is just digging through all of that piles of dirt, right? We kind of thought like maybe we can do something different, and that's exactly what we came to one of our customers and say, hey, we want to automate all your security scanning, and they like say to us, no. We're like, why? They like, you can't. Like, no, we can. They like, okay, prove it. Right, and we kind of went to and start thinking about how to prove it, right? And the reasonable proof was there was just to build a POC, right? We kind of build a POC in a couple of days and show that we technically can be one step closer from the situation, which is everywhere, to the situation where we want to be. And 1% is not like a big thing, but they like, okay, let's try. And we started doing, and we started from a pilot. And for a pilot, we have a plan, right? And the plan was very simple. We need to run every scan in a CI, which is like obvious, right? All the scans need to be fast enough to be CI friendly, which is also obvious. And then not obvious thing. We need to assume absence of a security engineer in the teams and produce the results which will not scare developers. Because usually, again, back into my previous statement, it generates just enormous amount of noise. And like if, for example, we will throw all of that noise into Jira, right, no one will ever look there. Ever. They will be like, stay there for ages. And like that's exactly what most of the people who is trying to adopt security now see. Because that thing just doesn't work because of that noise. And I go, okay, We can try. And the last, which is also a bit of a tricky thing, is kind of dynamic scanning. Dynamic scanning in the security is something similar to the AI and building like automated test. Is there, but it's useless, right? Like, and we're gonna customers say to us, okay, do something with it. You kind of smart, do something, and like we okay. The experiments I will show today, it's kind of a bit of a made up in terms of it's not a customer's code. I've took the public repositories, right, to demonstrate the approaches, to demonstrate how it actually works, and how the standard approach is different from what we've implemented, and we'll also show where you can go and kind of try to apply that approach on your project. So I've took the public repository, like not a random one, but it's like at least a public. Right, that's and run the standard. That's a Java project. What's the standard way of scanning issues in Java? The code scan. Now we're talking about the static scan, the code scan. Sonar, right? Sonar cube and Spotbox. Right, exactly. That's what everyone do. Sonar cube and Spotbox. That's exactly what I did. I took these projects, I ran Sonar cube, and I ran Spotbox. About 20 minutes, 24,000 of vulnerabilities. No one ever will look through that number. Ever. No way that gonna happen. In 90 minutes, come on, who gonna wait this? In the CI? No. So like that's the case which is happening, right? It's kind of, it is there, everyone does that, and what percent of people in audience actually work with that issues? Like maybe one hand at least? No? Okay. With fixing that issues. Yay! 2. Awesome. That's like about 0.5%. Well, that's good. That's good. Right? And we kind of start thinking that maybe that's not because of the tools are bad, right? The tools are awesome. Maybe the results they produce could be a bit enhanced, or approach how we deliver that results to the developers or to the QEs, maybe actually enhanced. We kind of took we call this sync carrier, right, and run with the Spotbox. Exactly the same tools, exactly the same results, right? But it took like 3-4 times less in terms of the time, and the amount of vulnerabilities technically which we kind of found was smaller. But that's not because we missed, that's important, that's not because we missed the issue, but because we group the issues. Because the idea again behind that is like we don't want to raise 3 or 4 tickets for a single file which could be fixed by a single commit. It's pretty straightforward logic, right? So we're just taking vulnerabilities found in that file, like by same type, that's important, right? Same type vulnerability, same file, group it together, that's a single issue. Right, but 4.5K is also sound like a bit too much for a regular person. Again, okay, what the next step? And the next step is pretty obvious, right? Let's eat elephant by slices. Right? It's not a frog, it's an elephant. Let's eat it by slices. And again, okay, we'll implement the outcome filter, which is just very simple, just saying, create me only critical issues. I don't want to see anything else, only critical. Right? And like when you're saying only critical, you're getting not 4.5K, but you're kind of getting 5. 5 is a good number, right? 5 is not as scary as this one. And like at the end of the day, right, we are getting 5 in Jira, which already can be addressed. And as soon as the 5 addressed, right, you can kind of, okay, now let's add a couple more and like 10 more, right? But at least it's kind of iterative approach, right? And you're just fixing, and you're controlling them by a single parameter in your CI job. Just literally, it's not technical in the CI, it's in your Git, but at the end of the day, it's just a parameter which is being consumed by your CI job and kind of just increasing the amount of output gradually. And that's about it, right? That's about it. Nothing more. We not reinvented the tools. We start to rethinking the approach, how we're delivering results. We assume that the tools for static scanning is out there like for years, right? And probably like there are a lot of people who's smarter than us is already like done some job and they're really finding at least something useful. And yeah, that's where we ended up. That's one of our so-called like enterprise level integration, which called PTII, which is by some reason reports in Russian. We're like, okay, you're reporting in Russian. We will create Jira tickets in Russian. Right? No translation, no Google Translate. Let it be someone else's job. Right, and like we are an international company, so we kind of have a couple of people who do not speak Russian, but they need to deal with that. That's kind of limitations. Not the tool limitation by itself, that's like an integrate, like the software that we are integrating with. But at the end of the day, that's like an example of issue that we are creating automatically. Right, so basically the developer gets the called job offer, right? And in this case, it's a ticket which describes what is bad about this vulnerability and how to find this thing in the code, which is important. There is like a yellow one, right? That there is a code flow, because that ticket is actually like that huge. It just don't fit into the screen. So yeah, that's a Git. We've open sourced that static code analysis, right? It is there. We'll kind of see in the end of a slide how it works in the real world, right? Any questions, concerns so far? No, that's good. Not as good, but still fine. And that's actually what we've put underneath to actually make it work. Because like there are millions of different languages, and millions of different languages being scanned by millions of different tools, and millions of different tools produce very various, I would say, outcome, right? And in order then to be able to put that outcome into the somewhere at least, right, in sort of human readable format, we kind of get back to the roots and start using 20 years old technology, which is like based of every ETL, it's canonical data model. It's very simple. You're just taking whatever you have, trying to put it in the very specific shaped box, right? And this specific shaped box then have a connectors. I just kind of make it as an example. It just have a connectors to wherever the tools you are going to export in this case, right? In our case, we have a couple. We kind of either can do it in HTML or JUnit. JUnit is mostly for Jenkins, right? The report portal, right? I will describe why we actually use that thing, right? And the Jira. Jira is important. Like most of the people use Jira and automatically created issues in Jira makes life easier. But with the Jira there is a trick, right? When you start automatically create the issues in Jira, the first thing comes to your mind, how would you avoid creating a duplicate? Because eventually everyone will kind of abandon using a tool if a tool produces a duplicate, right? The only reasonable way we found it was like how it works. Yeah. The only reasonable way we found is to create some sort of unique key for every issue. We actually borrowed that approach from the product called OWASP Defect Dojo, which is kind of weird product, but they have the code which we could borrow and now it's extending it. And we borrowed yet another approach from them. They call it deduplication on the go, which is not actually work pretty well, but kind of tuned it up and actually it actually works. In order to do that kind of grouping, we need to create unique identifier for every issue we find. So, and for different type of tools, identification of uniqueness for the issue is different. So we kind of creating, that's a simplified again thing. We're just creating this subset of a fields. In this case, it could be like any subset, but which identifies that that particular issue is unique for that particular tool, right? And then if it reproduced, we added the if statement. Ifs is our everything. Right? You just extend wherever you need to extend to kind of do not lose the data. That's important, right? Because like if you just do a deduplication, you may lose some important uh, entry points or important data, uh, which is like will be handful when you're trying to reproduce, right? Which is again pretty straightforward. The next thing is what I was saying, the filtering the false positive. Automatic filtering of a false positive. Initially, when I've started, I mentioned that there are like about 85% of a false positives, and we need to filter that somehow. We use report portal for that. Because report portal have some sort of an AI which is based on the CNN machine learning algorithm, which kind of need to be tuned a bit in order to make it work. But yeah, we kind of throw everything to report portal. Report portal then say us which is it like that's a product bug, that's not an issue and things like that. And we get in Jira issues out. That's one of the ways, which is in matter of fact the most advanced way we have now, but kind of, and it haven't worked from early beginning. And it haven't worked not because the report portal was doing a bad job, right? But because like our engineers who was onboarding the product, like there is a thing that you need to create this training data set, and to create that training data set is like a nightmare when you have a lot of the issues, right? Then you need to kind of tell the report portal which should be treated as a bug, which should be not treated as a bug, and things like that. And we can kind of decided also that we probably need to automate that piece as well, creation of a training data set. We work with a team, with the report portal team, and actually created yet another open source solution, which is like the equals analyzer, which could be used as a second automated analyzer in the report portal, technically first, with the higher priority, right? And then the creation of a training data set will be much easier. Because like basically the logic is follows. When the issue comes, the first thing it searches is if this issue appeared ever before, like exactly the same issue. And if it is, right, it just marked it straight away. That it is kind of, with the state it appeared before. Which is not true for the closest nearest neighbor algorithm, because it need to have like significant data set, at least 5 runs or wherever, otherwise you will not get accurate predictions. And in order to avoid that type of a work, we created this thing, right? Which is kind of natively in report portal. You can just integrate it, just launch yet another service, and automation will go a bit smoother. And that's pretty much was the success of a reporting, right? Because at the end of the day, what we got very few issues created in Jira. We had got control over the flow, how that issue, how intensive that issue in the Jira, right? Like how, what amount of issues we are putting there. And there was very big percentage of correct hits, I would say. Right? Because they're fairly saying we've almost eliminated the false positive which has come to developers. It's still come, right? Don't get me wrong here. It's still there, but there are a few of them, and actually people think that that's okay, we can close that, we can do one fix and kind of forget about it, right? And then the next story comes, right? So the reporting. Any questions, concerns? That's a good question. That's exactly why we developed this thing, to minimize that time. Because what you actually need to do, you need to process the first run, which is usually take you about like, and we got a filter in the beginning, right, which is kind of limit the amount of output you're getting. Then the first run, it's take you about like a day, for example, right, because it still could be huge, but the day is the worst case scenario, I would say. Then every next run is taking you minutes because there are only few issues may be new, right? Because everything else is handled by this thing. And you don't actually even need to think if this issue have ever like appeared before. It will be handled automatically. And like automation is a good thing. A robot need to do the work of a robot. Anything else? Okay. Let's go to another interesting piece, the dynamic scanning. Because like the next challenge was how we will create the dynamic scans. And like, again, a bit of a theory. Imagine that that's your system. That is quite complex. It's kind of have entrances, exits, and all of that thing. And let's imagine the real intruder who do not have any kind of logins, passwords, or whatever the stuff. So the only way this dude can enter and like enter the system is through the open gate, right? And another one, which is a bit more often, right? It's an internal intruder. It's someone within the organization with some specific subset of permissions, right? And kind of can cover also some parts. So like in terms of an external intruder, I don't know if you can see it or not, it can cover only this piece, right? Then, for example, the internal intruder with the pink name and the pink gate can definitely cover what this dude can cover, right? And the next piece. And none of them will actually get to a cheese, right? But that's maybe that will be enough. And I've kind of, okay, let's give it a try. What we do? Another experiment. Very simple. You can repeat it pretty easily. Taking something, in my case, I've just took a report portal and deployed it on my local machine, right? And run different types of scans. That's what I get. That's the results. That's the results. The external intruder dude was running for 2 hours, haven't found any valid issues. 100% of an issues were false positives. Like it absolutely useless. It may find some issues, right? May technically, but not in this case, right? And not in the most cases. Then we okay, let's do an internal dude. Internal dude converted my laptop to a heater, ran for 20 freaking hours, produced like 200 findings, and again 99% were false positives. Not very good results. And especially like 20 hours, come on. No one will wait that time in a CI. Because like how much time do you have in a CI for that type of an exercise? 5 minutes, 10? Like not more than that. At least according to the latest researches from Google, you kind of have about an hour to deliver the code from a commit to a production. So for all that testing exercises, you like how many? Like half an hour done? Half an hour for everything? Not 20 hours for that kind of red dude. right? Again, okay, maybe we can find out something more. And we found out, we took the automation. Existing automation on the project, functional, performance, in our case performance. I've tried with the functional, works exactly the same way. Run through the security tool as through the proxy to form the scan profile. Oh, the only difference, we removed all the logouts from automation. None of the logouts. So all sessions need to be alive, right? Removed all the logouts, run the automation through the security proxy, execute the scan. Technically, if your automation is good, you will be able to cover everything. If your automation is bad, then kind of you have some other job to do rather than security, right? And that's what we get. No, I haven't changed them with place, but that's fine. That's what we get as a result. It fired. It was actually working only 25 minutes. I just forcefully stopped it. 25 minutes, 95% of false positives, right? In compared to 20 hours, 19, and like 99% of false positives. And like it's actually found pretty valid bugs. I'll show you in, not for report portal, but for other tool, I will show you like the valid bugs. In the report portal, I have my favorite, which is also the case. Right, in some cases, then this tool found the issue which is treated as a low priority. In this case, it was reflected XSS, which is basically means we are sending the RESTful call which contains an XSS, it responds us, and in response, we contain the same kind of JavaScript, which is marked as an reflected XSS, which is a low kind of severity issue, which is may or may not cause an issues on the real products. That wasn't the case with the report portal. Because then when I'm started to validate the issue, right, I find out that this particular reflected XSS done something like this. Boom. And that sounds like pretty critical damn thing, right? Because like literally everyone who would go to that system will be like lost, right? And this is scenario, that's very important, that the third type of vulnerabilities, which technically, oh, that's hell is like running for ages, so we'll get back to a slide back. So, and that type of vulnerabilities is the third type of vulnerabilities which also need to be covered, but not with the tools. It needs to be covered by functional automation. Because eventually, all the scanners is built on a pretty simple principle. If it's able to fire a single request and get some response with sort of something like an error, then it's treated like an error, right? But when you need to fire a chain of an action, that's not about the scanners. They able, like as I showed, they able to identify that type of an issues, right? But then to kind of add these issues to the regression suits, you kind of need to add that to your functional automation scripts. Just like specifically, as in every bug you do, if you find a bug which is not covered by automation, you're creating a ticket describing do this, 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 and that. Done. Right? Then have a summary and have a demo. Let's go here. So, currently, all these products which I show you, like technically for a dynamic and for a static scan, are open sourced, right? You can take it and just try it on your project, like starting day one. Examples of how to do that is also open sourced, and I'll show them like right now. But the important gotchas we got from there, you definitely need to run the security test as a part of your pipeline. If not now, like in a year you will be forced to, because like it's better to be ready in advance, right? Then not all the results are useful, right? So you potentially want to kind of reprocess it, and that's why we actually started to creating the open sourced version of our this reprocessing logic, because like not only us need to reprocess, everyone need to reprocess. Otherwise, no one will use it. Like we have two people in audience who is actually processing them now, right? Kind of. Yeah. And let me show you how it really works. That's a Jenkins. Everyone saw the Jenkins. Where is my mouse? I see the Jenkins, but I don't see the mouse. Okay. Something strange happened. Hey, oh, okay. Now I see the mouse. So, for example, that's yet another tool which has come as a demo to that project. We have this demo does blind, which is the blind scan, right? The blind scan is when you non-authenticated, just doing, I will show you the code. Test execution, that's the results. That's the code. That's the code of a blind scan. Very simple, very straightforward. Not actually maybe, but it's pretty simple, right? Just opening the URL, running the spider. I believe everyone would understand how the spider works. It's just trying to get wherever it's kind of can, right? After the spider, it forms some sort of a scope. And after that scope, we kind of run an active scan, which is basically trying to fuzz the parameters of the request in order to get some sort of vulnerabilities in the response. Right, that's it. And there is yet another one, a bit more complicated, but in demo purposes, simplified, which is doing exactly the same, apart from a block in the middle, like this one, which is just saying put your functional or performance or whatever shit test there. What it's actually doing, I'm just running a couple of URL requests to the applications through the proxy. Right, one of them is doing registration. I understand that it's not like very visible. Like, yeah, sorry for that. One of them is doing registration, another is doing a login. Very simple, right? And then doing exactly the same. Spider, active scan, report, reprocess the results, generate the data, done, right? Pretty simple. And again, for the demo purposes, I've done Docker and Docker to kind of demonstrate that that's actually not a big deal, which is technically not a Docker and Docker, it's just a Jenkins syntax like that. It's all like running on the same machine, but yeah. It's not a big deal to kind of put the automated test somewhere in the, to put the automated test through the security, this tool as a proxy. As a result, that's the first one. That's the first one, which is without this couple of C URLs, right? We have, like in a simple numbers, we have 4 low vulnerabilities and 1 medium, right? They all pretty detailed to some extent, right? And that's the result of a second one, which have very small difference, but very important. After the second attempt, we got an SQL injection, right, which wasn't on the first one. And in terms of a time, an SQL injection is quite critical thing. In terms of a time, authenticated scan run for 5 minutes. Non-authenticated scan run for 4 minutes. And in both cases, it's not a big deal, right? But on one case, we haven't got the real critical issue. On another case, we got it. With, again, pretty handy steps to reproduce. It's an SQL injection, right? It's like just take this and put it in the URL, done. You've kind of reproduced, kind of in return you will get the data. You'll get actually the Boolean, I believe, Boolean evaluation there. Simple, straightforward, very easy to implement. The same exact thing for the static analysis, right? It's all available in here, right? in a GitHub. You can just go and get it. Go get and apply. And which is like yeah, there are a lot of them. It's only one, right? But there are kind of a lot of different stuff. This one is for sorted documentation, which is not really much there yet, but yeah, and they are built continuously on the Docker hub, so they're all ready to be used and consumed. Kind of just low-hanging fruit. Take it and try it. Right? Questions, concerns? Go for it.
Should I repeat?
No, no. You're saying how we will consider duplicates if this issue is already created in the system.
Yeah, and maybe fix or maybe it is not fixed. Will system during first filter phase think that is duplicate or you have the way
Like
around it?
we actually don't care if the issue were created before, not by this tool, right? We kind of currently we chose the hash kind of hash comparison. So even for the Jira, like for the issues created in Jira, we're just searching if in scope of this project there is an issue with such type of a hash, then we kind of consider that as a duplicate.
Okay, but still, if developer fix the issue, we need to perform confirmation testing, right?
Yeah, but that's in the
So
CI.
if we run the same test again, will it be considered this test duplicate or it will perform correctly?
It will perform correctly. Like how it won't consider that as a duplicate, right? Because the duplicates, if it's in Jira or not, for example, or if it was in the previous report or not, we that's a call to action. Either we'll do some action or not. And in this case, we decided to do not take an action, right? And do not take an action was also done by a reason. Because like we got one of an enterprise integration was with the check marks, right? And the check marks is the security scanning solution which scan .NET project for years. And in order to kind of minimize the scan time, we had to narrow down the scope of a scan to a commit base, right? Which is basically means that you will not get the same issues every time, which means that we can't close issues automatically.
Okay, thank you, I get you.
No problem. Next question was somewhere there. It was here. The gentleman.
Yes, thank you for the talk. I have a question whether your tool works with other dynamic scanners like burp suite or some specific fuzzers.
We have ability to configure it with the burp suite.
Can you show it?
Which is not something we are going to open source.
Okay,
because
thanks.
of a reason, right? Because burp suite cost like about $400, right? The single license. And the single license have a limitation, right? Single license have a limitation on activation, and like we actually like we found a way, right? We can help to build we can help to build that type of container, right? And can help to run it, right? And we want to publish the paper how to craft this container by your own, but we won't open source it. Right, so you kind of can do it, take it, and use it, because, like, again, the burp have very specific limitations. Right, and currently we have ZAP, we have Swiss3AF, we have Nikto, we have integration with Qualys VOS, we have Mascan, we have SSLIs, we have Arachne, right? I believe that's it. Maybe something missed, but it's all like we have this container which is like the dust one, which is like almost like a Kali Docker, right? It have a bunch of that weird stuff, and the configuration of execution can be done in two ways, right? And one of the ways which most of the people use, right, who's just taking and is the config file, right? When you just specify, okay, Like run me the muscan with this parameter, run me nmap with this parameter, run me zap, run me nictar, run me with 3af, and then I will just disable like my authentication, do the scanning, scan everything because I don't want to bother myself. Right, that's one of the types. Another type is like, as I showed, we can feed the data through the with an automation, and then kind of perform deeper scanning, right, and provide some valid issues. But in some cases, even the basic scan also work.
Thank you.
So yeah, there are a couple. Oh yeah, there is a with3f, and yeah, we have this Qualys WAS integration as well somewhere. It's in documents. It's like in here. That's a long read, right? With all the possible configuration. Yeah, that's the Qualys. Go for
Uh,
it.
I'm sorry.
Hey.
Uh, as far as I see, you perform scanning, but do
Yes.
you perform any kind of cryptographic analysis?
No, not yet.
Okay.
Not yet.
Thank you.
That's definitely like we have some sort of swords that we kind of the first thing in the list, right after we deal with that, will be infrastructure and containers, right? Because they fairly saying they have a bigger market share, right, than the cryptographic analysis. And cryptographic analysis, you know, you need to be smart to do that. Any other comments, concerns, ideas? No, good. Not good again, but it's kind of we have what we have. Yep, that's the repositories. Thanks a lot. Uh, you're free to try. In case of any issues, just write me down in the Git. I will respond. Right? That's like all we're trying to do for living. Respond to a Git. Thanks a lot, guys. Thanks. Bye bye.